Now, in the United States, they do a DC arc emission spec burn the same way, except they only burn for 15 to 20 seconds. And everybody here says everything's red that's going to read. Now, that's the standard thinking here in this country. Yet the Soviets say that in the first 45 seconds, nothing reads but lead. And it's only when you get to 50 to 70 seconds that palladium will begin to read. The lowest temperature, the lowest vaporizing platinum metal. And as you continue to burn, then ruthenium, rhodium, and platinum begin to read. And and this is the temperatures that they vaporize away. It's kind of like boiling water away from oil, and then and they go off of the sequence of the vaporization temperature. But it goes all the way to 175 seconds when they're taking off, rhodium, platinum, iridium, and osmium. And so if you go back now, the one before it. All right, so we had a fellow in the Phoenix area. His name was Siegfried Brimmer. Now, Siegfried Brimmer, you could hardly understand his English. He had a very heavy German accent. And he had been trained as a spectroscopist over in Germany. And this is his resume. And I bring this only so people can see, from 1939 to 1945, he went to public school in West Germany. 1945 to 51, high school. 1951-54, Dortmund, I don't know, it's all German, bunch of German words. Anyway, in West Germany, a certificate of practical and theoretical training, and then his work history, 1954 to 59, his production of quality control and technician at the Portman-Norder, anyway, German. And he's got a certificate. And he was a petrochemist at the Steel Company of Canada Limited. In 1966-68, he was the supervising spectrochemist at W. Kramer and Company, smelters and refiners of metals, copper, alloys. 68 to 70, a spectrochemist with Martin Marietta Metals Division. Anyway, you can see his credentials here. It's very immense. The guy has done a whole bunch of work, all with all big companies. And he had letters of recommendations, which I'm not letting you see all that because it's too long. But everybody wrote him great reviews when he left the company and all. He is really a good spectroscopist. So, at the very end, when he retired as a chief spectrochemist, metals technology in California, he actually was building and designing spectrochemical equipment. And he's actually constructing equipment to do DC arc emission spec analysis. And he was given the machine that he had designed and built for the company to sell. They had an order for this huge big machine that had a 3.5 meter arc on the dispersion, which means the light is broken up to 3.5 meters in size. The line spectra could be seen over 3.5 meters. Now this is a huge instrument, people. To give you a perspective, most universities have 1 meter to 1.5 meters. He had a 3.5 meter instrument, huge big machine. And what this gives you is the ability to shoot the spectra and to divide the lines way far apart. The bigger the arc, the greater you can separate the spectral lines to determine what you really have. And I went over to him with a Soviet text, and I said, "This is what I want you to run for me." And he said, "Oh, that's not necessary." He said, "We Germans are the best. We know metallurgy. This is not necessary. That's just Soviet, no good." And anyway, if you've ever dealt with a German technical person, they're extremely arrogant and extremely matter of fact. Well, they are some of the best people. They really are. But you got to deal with them as people. Anyway, he said, "You will have to buy all the standards. You will have to pay for modifying my machine to do the long burn times. You will have to pay for me to do this work. And then when I do it, you will have to pay for my time and everything. And then I will tell you what I get." And I said, "Fine, I'll pay for it." So it cost me like $3,500 for the very first run of material. But the sample I brought to him, it read these elements. And he was totally flabbergasted. And if you go to the forward it. Yeah, here it is. Anyway, this right here, the GW sample, June 21st, 1982. If you see, platinum is 0.05 to 0.3%. Not ounces per ton, percent. Iridium is major. Now, by major, he goes only up to, I think, 3%. No, here's one, he goes to 5%. Well, by major, he's saying it's over 5%. It's beyond what I'm calibrated to read. To read that accurately, I have to actually dilute the sample down and make it emit in a lower amount because it's beyond my capability to read the amount. The osmium is 0.3 to 1.5%. Rhodium is major. Ruthenium is major. Anyway, and of course this is all the other, cadmium, cesium. He didn't, and iron, of course, is a high amount. Anyway, he just says, Dave, these elements cannot exist in the quantities that I'm reading them. Everybody knows that. Now, for perspective, I need to tell you that the best known mine in the world is in South Africa. And these people go a half-mile underground and work underground at a half-mile to get ore that has 1/3 of 1 ounce of all the platinum metals in it. 1/3 of 1 ounce per ton. And this sample right here was actually an acid dissolution of a rock on the side of a mountain. Now, he had no idea how I produced this. He just knew I came to him with a sample. But he was reading numbers. And the amazing thing about this, people, is if you go to a spectroscopy, he'll say, well, maybe it was interference. Maybe it really wasn't these elements. When you do the long burn time, everything reads in the first 15 to 20 seconds. And then it goes quiet. Nothing is reading for 30 seconds, 40 seconds, 50 seconds, 60 seconds. And then when it starts to read palladium, nothing else is reading. And when palladium stops reading, then here comes the, I don't know which one's the next, rhodium or, anyway, they read in the sequence of their vaporization temperatures. And so you have to boil one completely off before the next one starts coming. And so when the next one is coming off, nothing else is coming off. There's no way to say there's any masking. There's no way to say there's interference. No way to say there's impurities causing the reading because nothing else is reading but these elements. So he accused me, well, he didn't accuse me, he asked me not to get in this lab. He said, get out, get out, get out. Go away. I didn't know what I'd done. I paid for everything. What's the big deal? Anyway, he wanted to check all this, be sure it was right. So it was about 4 weeks later before I heard from him again, and finally his wife calls me up, and she says, yeah, Mr. Hudson, Ziggy wanted me to call you and tell you that he needs to meet with you. So I come back over, he says, well, I checked this, and these elements really are here. And he says, this is unbelievable. And I says, yes, I know. Well, I took him many other samples too, the exact same material, prepared various different ways, and everyone read no platinum metals. And it's the very same material off the mountain, the very same material prepared different ways. Only when I prepare it the specific way I prepared this did it read. So people, it is not the long burn time, like a lot of people thought when they read this before. They said you have to just burn, 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 burn till it gets so hot it'll come off. No, it has to be prepared correctly before it will read. Okay, and there's some misunderstandings. When I talked the first time, I told you about this and people said, oh, it's that long burn time. No, it's not the long burn time. It is the specific preparation of the material that must be performed chemically first before you take it for analysis.